Yes, hey, welcome back. And yes, since I solved merge case sorted arrays, I think it only makes sense that I do the same for linked lists also. And to be honest, I don't know why it is given as a hard problem. Mainly because there is, I think, zero, like very little change between the code of merge case sorted lists and the merge case sorted arrays. So this is, yeah, this is medium problem. It's not hard problem. But hey, if it's given hard and you solve a hard problem, then pat yourself on the back. Yeah, again, if you don't know how to solve the merge case sorted array problem, what we'll do is that we will take all the first elements of the question will be like you'll be given a list of lists in merge case sorted arrays. You'll be given a list of lists, and you have to all the lists will be sorted, and you have to like solve the entire list and get the output. And what you do is that you take the first element of each list, put it into a heap, take the current there are many ways to do that also. What I did was that I took the entire array and put it put it into the min heap. I mean yeah, a min heap only. And how min heap works is that it generally sorts based on the first value. So it will like if these were all arrays, I would like it would be sorted based on the first value, like one, and since one are both same, it would take the next value, which is 4 and 3, and then it would sort based on that. And yeah, so yeah, you can yeah, that's how you call the merge key sorted array program. So you'll take the values, you'll pop them out, and you'll add it to the list, and then put back the original the modified list. So the same thing we'll do in merge key sorted lists also, but rather than putting the entire what you call rather than converting it to an array one, you'll just put the entire list, and uh, you'll have a current yeah, when you put the entire list, the head will be pointed to each of them, and in each iteration you will just take the head value, put it to our new list, and then move the head value to the next value. Okay, that's pretty simple. So but the only thing is that since minheap actually wants an integer value to compare. Yeah, so to compare one and this one, it actually needs integer value, so you can't directly pass what you call the list node itself. So what we have to do is we have to define a custom comparing function, and then set the underscore LT method of list node to the to our custom function. So first let's get that out of the way. Yeah, you'll get the current node and the other node. If you know about a comparator, it's the same as that itself. It's the same as comparable. You get this and other. So we are taking current other over here. So what to do? Return the current dot value is less than the other value. Yeah, and if they had asked you to sort it based on descending order, I think you could just swap this around, and it would have worked. And yeah, again the assumption would be that the entire given list would be sorted like in descending order itself. And yeah, now let's take a list node dot it will have a underscore less than method. This is the method which it uses to compare the two list nodes, and you will directly set it to a custom compare. And then what we will do? Now declare the heap, and for each linked list in list, so what you do? Only if the linked list exists. So if there is some null value, don't directly. It is pretty obvious if it's not put that inside the heap. So if the linked list exists, only then into the heap, to our heap you push the linked list, and yeah, now you won't get any error because you are actually defining the custom function to compare the value. So now you directly can continue. And now what you have to do? Declare the answer as a new list node. Or yeah, and initially it will have the head will be none, and have a head which actually points. No, let's not call it head because we will actually change the head. So it's actually the current pointer which will actually point to the answer. And then what you have to do? The same thing which you did with merge case sorted array. So while heap exists, pop out the leftmost value from the heap. So kernode will be equal to the heap. Yeah. Now what you did, you actually popped out this value. So according to the definition, this will be first, this will be second. So you popped out this entire list, and that is actually the kernode. The kernode is actually pointing over here initially, because kernode is actually the head of that list. And so if there is by chance if there is no kernode, then just continue. This is just Descartes law. And what happens if the kernode exists? Then what you have to do? You have to take the cur and take the next of the cur. Like cur will have since cur is a list node, it will have a yeah. The definition is given over here. The cur will have a next property, and that next property will actually be set to the cur node. After doing that, take the kernel and yeah, this is just like increasing the ID, index. And what you have to do after doing this, you have to increment the cur pointer also. Yeah, imagine like we are going in an array, and the next is actually telling take the ID, ID, not ID, man. Index and increase the index by one. Over here also, we're telling to take the index and increase the index by one. And if the cur node exists, then what you have to do? Into the heap, into the current heap which you're like using, into the heap, push the cur node. And by now, what will happen is, while the entire heap gets evaluated, you will actually have the value in your answer. And since answer is, yeah, this is actually a dummy node and it's having the value none. So what you have to do? You have to return the dummy or answer. The dummy actually taking dummy nodes are like really popular in linked list program. Let's just compile it and check if you made any mistakes. Yeah, it is working as expected. And let's just commit it once. Okay, have patience. Patience is a virtue. Just submit. And there you go. It works. It is like super. Yeah, it is efficient. And I don't know, like there are no other solutions in front of this solution also, but still it's not 100%. So it happens, but hey, at least we solved a hard problem. Yeah, that's all for it. Thank you.